This is day 6 of AMC 10 analysis, where I go over AMC 10 problems. Today we're going over the 2025 AMC 10A problems 13 and 14. Problem 13. In the figure below, the outside square contains infinitely many squares parallel to the outside square. The ratio of the side length of the square to the inner one is k, where k is between 0 and 1. The area of the shaded portion of the figure is 64% of the area of the original square. What is k? Since the problem is asking us for a ratio, we can assume without the loss of generality that the side length of the biggest square is 1. Now let p equal to k squared. The area of the figure would be 1 minus p, since I would give the red area that I just colored, plus p squared, which will give the next red area that I just colored, and then minus p cubed, and so on until infinity. This can then be factored into 1 minus p times 1 plus p squared plus p to the power of 4, which by the sum of an infinite geometric sequence equals to 1 over 1 minus p squared, which is 1 over 1 plus p. Then this equals to 64 over 100 because that's the ratio of the shaded area to the area of the biggest square, and the area of the shaded area is 1 over p plus 1, while the area of the biggest square is 1. And 1 over p plus 1 divided by 1 is just 1 over p plus 1. Anyway, solving for p, we get 9 over 16, meaning that k equals to 3/4. Problem 14. 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that both the 2 students and teachers will be adjacent? For this problem, we're going to assume that the teachers are indistinguishable, meaning that we just need to choose the 2 chairs that they sit in. However, if we assume that they are distinguishable, we will still get the same answer, which I'll show you in a bit. So we can first sit the teachers, and obviously there are 6 ways to do this as shown. Then once those 2 teachers are seated, we can assume that they are right there. It will kill off 3 of the 6 possible previous options, giving us 3 more. Then for the denominator, there are 6 choose 2 ways to put the teachers, and then 4 choose 2 ways to put the students after that, giving us a denominator of 90 and an answer of 1/5. Now if we assume everyone is distinguishable, meaning that the teachers and students can swap, there are 2 ways for the teachers to sit and same for the students, but this must be put on both the numerator and denominator so they cancel out, giving us the same answer.